So in this video, we're going to use the difference quotient to find the equation of a line that is tangent to a radical function. So it says find the equation of the line that is tangent to the curve f of x equals the square root of 2x when x is equal to 2. So in GeoGebra Classic 5, I went ahead and drew a picture of, or constructed a picture of the situation. So we have the function f of x equals the square root of 2x here in green. When x is equal to 2, there's an ordered pair on the line f of x, which we could find by doing f of 2 equals the square root of 2 times x, but x is getting replaced with a 2. So we get the square root of 4 equals 2. So we have the ordered pair 2, 2 on the function f of x. And we're being asked to find the equation of the line that is tangent to or just touches f of x at that point. And again, just like in the previous example, a tangent line is going to have in slope-intercept form, the form mx plus b. So we first need to find the slope of the tangent line, the slope m. And the slope of a tangent line is given by the limit as h goes to 0 of the difference quotient. And this is represented by f prime of x, y prime dy dx, slope of the tangent line, derivative. To find the slope of the tangent line, we need to know the derivative of f of x. So we're going to find the derivative f prime of x by applying the difference quotient, taking the limit as h goes to 0 of the difference quotient applied to f of x. So the first step is to replace every x in f of x with x plus h. So I have the square root of 2 times x, but I replace x with x plus h, minus, from right here, the original function f of x. The original function f of x is just the square root of 2x, and it's all over h. And then we're going to go ahead and use the technique that we've used now in 2 previous homework assignments. We know that we can't plug 0 in for h. We'd get division by 0. So what we're going to do is rationalize the numerator. So I'm going to multiply by the conjugate of the numerator. So it's going to be 2 times x plus h and the square root of twice x. And because this is a minus, I'm going to replace the minus with the plus over here to make the conjugate. And I need to multiply by 1 or I change the value of my expression. So I need to multiply by the numerator. I need to put what I have in the numerator also in the denominator so that this ratio is equal to 1. So now I'm multiplying by a funky form of 1 equals the limit as h goes to 0. When I multiply the numerator, I want to recognize because I am multiplying a product of conjugates, the middle terms cancel, and I'm just going to get an a squared minus b squared form. So I get the square root of 2 times x plus h times the square root of 2 times x plus h is just going to be 2 times x plus h minus the middle terms are all going to cancel, so I'm going to get the square root of 2x times the square root of 2x, which is the square root of 2x squared. So the square root's going to cancel for me, and I just get a 2x sitting here. And this is all over h. H times the denominator sitting over here. So square root of 2 times x plus h plus the square root of 2x. I'll bring my fraction bar out to cover all of the denominator, equals. The numerator can be simplified. I can distribute the 2 into the parentheses. I get 2x plus 2h minus 2x. I didn't put my limit notation down. I still have to say the limit as h goes to 0 until I find the limit. I have to keep saying it. So 2 times x by distribution plus 2 times h by distribution minus 2x is going to be all over h times the square root of 2 times x plus h plus the square root of 2 times x pull my fraction bar out and my radical sign over the entire thing. So 2x minus 2x will go away, and that will leave me with the limit as h goes to 0 of 2h over h times the square root of 2 times x plus h plus the square root of 2 times x. And then what I want to recognize is that as long as h isn't 0, and it won't be because we're taking the limit as h approaches 0, but we're not letting h equal 0, so h divided by h is just going to equal 1. So I wind up with the limit as h goes to 0 of 2 times 1 is just 2 over the square root of 2 times x plus h plus the square root of 2 times x. And now here's why rationalizing the numerator was useful. Now there's no h in the denominator except for the x plus h here. So if I plug h equals 0 in here for h, what is going to happen is I'm not going to cause a division by 0. So I can go ahead and drop my limit notation and say, hey, for this expression, if I plug in h equal to 0, nothing bad happens. I just get the square root of 2 times x plus 0 plus the square root of 2 times x. I'm going to pull this over here. So f prime of x is going to equal 2 over x plus 0 is just x. So I wind up with the square root of 2 times x plus the square root of 2 times x. So there's 2 roots of 2x, so I get 2 times 1 plus 1 is 2 of them. And 2 divided by 2 is 1, so I wind up with 1 over the square root of 2 times x. So there's my derivative. So first step, calculate the derivative. Now I need to know the slope of this tangent line. But to find the slope of that tangent line, I just plug the input variable x equal 2 into my derivative function. So I get f prime of 2 equals 1 over the square root of 2 times 2, which is 1 over the square root of 4, which is just equal to 1/2. And so now my tangent line, which up here was going to be equal to mx plus b, now I know what m is. So I can replace m with 1/2. So I'm going to get the tangent line equals 1/2 x plus b. And now you take the ordered pair contained by the tangent line, the ordered pair 2, 2, and you plug it in. So we get replace t with an output of 2 equals 1/2 times the input x is equal to 2 plus b. So I'm running out of space here. I'm going to make myself some space by erasing this stuff here. So I get 2 equals 1/2 of 2 is 1 plus b, and subtract 1 from both sides, I get 1 equals b. So the final updated equation is going to be my tangent line is equal to 1/2 the slope times x plus the y-intercept of 1. So there's the equation of the tangent line. And I felt okay to erase this because you can always rewind the video to take notes. So it's not like it's permanently gone.